Okay, let's get started. So,
You do have the marker.
listen. Last chapter we had the exponent lesson that was all new stuff and kind of hard, right? And you still haven't mastered it yet. Probably need more practice. This chapter, it's probably this lesson. So, we're learning something called the distributive property. But really there's a lot of stuff we have to learn today. So this is going to be a 2-day assignment. So you see how it says 1 through 40? We're actually going to do that over 2 days.
So like 1 through 20.
Okay.
So due Friday.
Due Friday, yes.
Are you gonna assign something like tomorrow?
No, not assigning anything
I'm
tomorrow.
writing down
Besides
the-
that. Okay, shh.
You're done.
So we need to listen. You guys are done. I'm going now. All right. We need to start with the basics here. What if I said x plus x? What does that equal?
X.
2x.
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 Yes.
I mean, it's x.
Because, no it is not.
Oh, it's not.
So,
X.
why is that true? Because what's 3 plus 3? 6. But it's the same thing as 3 times 2, right?
Yes.
3 plus 3 is the same as 2 times 3. That's what times means. It means that many 3's added together. So x plus x just means 2 times x. 2x. Alright? What if I had x plus 2x?
3x.
3x's. That's basically 1x plus x plus x. So that's like 3x's. 3 times x. Okay? Stop. Pay attention. I just told you this is hard and you guys are goofing off. You need to stop.
You guys. Bro.
Alright. Let's see. How about, so what about 5x plus 7x? What would that be?
12x.
12x. Alright. 12 times x. Alright. What if I had x plus y?
X plus y.
X, Y.
Okay.
No, it's x.
What does xy mean?
Multiply x times y.
X times y. Is that the same thing as this?
No.
So this does not simplify.
So it doesn't change
It
usually.
doesn't change. You can't make it any simpler. What do I mean by simplify? I mean turn this big thing into this littler thing. Put as much stuff together as you can. So this one does not simplify. Okay, this idea is called adding like terms. If they're the same kind, we can simplify it and add them together. If they're not the same kind, we cannot simplify. Adding like terms. By like, they mean the same kind. Grace, are you paying attention? Sure doesn't look like it.
I'm writing down notes about
Writing down what?
that. Notes about that.
Okay. Let's see. Distributive properties, blah, blah, blah. Okay, how about 2x squared plus 3x? Do you think these are like terms or not?
Yeah.
Yes.
Whatever x is, x squared is going to be something different. So no, they are not like terms. So this does not simplify either.
Oh.
Whatever x is, x squared is going to be something different. Like if x were 3, x squared would be 9. We don't know what x is, but these are different numbers, different values. So they don't simplify. Okay, so that's idea number 1. We got lots to get through today. The second part, though, is I just need to talk about some definitions. So let me put 3x plus 4y minus x. All right. Definition number 1. These 3 things, I kind of accidentally, I've been using this word, but I didn't define it. Those 3 things that I underlined are called terms. 1, 2, 3. Those are called 3 terms. Okay, terms are separated by pluses and minuses. They are connected by multiplication. Alright, so I could make this a little more complicated. I could call that 3x squared y or something. That's still one term. Okay, it's all together. Alright, the numbers on the front 3, 4. What number is on the front of this one? No. If there's no number right there, do you guys know what number is right there? That might.
One.
1. You guys remember that? Well, okay. Those are called coefficients. The numbers on the front. By the way, if I had like a +5, that's still a term, that's still a coefficient, even if it doesn't have variables. It's called a constant, but it's still like, you guys remember we talked about constants on Monday? Anyway, the coefficients for this would be 3, let me erase that, 4, -1. Okay, if it's a minus in front of it, it's probably best to think of it as a -1 instead of just a 1. So the reason minuses and negatives look identical is because they basically are. So just think of that as a -1. And the 5 is just a 5. So those are the coefficients for that thing. And it has 4 terms now. Okay, got those are the 2 definitions we need. So far, so good? Are any of these like terms? Are any of these alike?
Y, X.
Okay, no. These are like terms. Like terms are things that are the same kinds that can be added together or subtracted together. Are any of these alike?
Y.
No, they're all different. You can't have one like term, you have to have 2 that are the same kind to add together. So those are, all 4 of them are different, so that would not simplify at all. Alright.
Commissioner,
Yeah.
what do you think would happen if somebody came to school to shoot them?
What would happen? They'd probably have to go in the office and call to get shoes or something.
What if they had no shirt on?
Same thing.
I'm on a socks. Pack some glasses in your head.
Alright, so
You'd be dead.
now here's none of anything that I just talked about is distributed property.
Oh, wait.
But that's what the lesson is called. I'm working my way there. All that was like you need to know these basics before you can use distributed property.
Oh my. Okay, so.
Okay, this is distributed property. So, what does distribute mean outside of math, like normally?
To
Okay,
Divide equally among.
pretty close. You're pretty close. It's more like pass out. Usually equally, yes. So if I distributed the calculators, I just handed them out to you guys. It doesn't necessarily mean equally. It could give more to one person or something. But yeah, it's like passing out. So can I simplify x plus 3? Is x plus 3 the same thing as 3x?
No.
No, because 3x means what? Times. That's not that. This does not simplify, right?
No.
But can I what does the 3 next to parentheses mean? Times. Okay, it doesn't mean 3 times x, it means 3 times whatever this is. I can't really solve it, but I can simplify it using the distributive property. So I'm going to distribute the multiply by 3 out on both of those guys. Okay, I can't do x plus 3. Normally we do parentheses first, right? But I can't do that. But I can do times 3 times 3. What do you guys think I can put for 3 times x?
3x.
3x. Did I really do anything? No. 3 times x is 3x. That just means the exact same thing. But I can't do anything.
Plus.
And then you bring down the plus, and then you can do 3 times 3.
Which is
9.
9.
So that's a little bit simpler than it was before. And you have to do these to solve certain types of equations. You guys remember solving equations towards the end of last year? Like
Sure.
x plus 7 equation equals.
Oh, yeah.
That's solving equations. So we're going to start that on Friday.
And like
It'll be
x.
Friday will be simple, like one-step equations, and then but it'll get every day will get a little harder, that kind of thing. But you guys have done this before. So some equations have this in it, and to solve it, you have to do this. That's why we're doing this. Anyways, let's see. Yeah, so that's basic distributive property. Now let's try something else. How about this one? So same thing. That goes to both. I can't simplify this, but I can do times 4 on both of those. What do you guys think 4 times 2x is going to be? 8x is correct. I know what 4 times 2 is. I don't know what times x is, but I can at least do 4 times 2.
8 is
Okay, minus 4 times 5 is 20.
Oh, it is.
Are we so far so good? Not too scary yet? This book doesn't do a great job of gradually introducing. That's kind of why this is a 2-day assignment, so we can, it's kind of a tough jump from 8th grade on this one. Pre-algebra has an advantage here. Okay. Pre-algebra, they teach it a lot slower. Let's say, let's do, okay, here's a new concept. Let's do x plus 2. Actually, let me make this like a 4 or something. All right, 3x times 4x. What do you think?
Well, that's.
Close. Okay. Do I know what x times x is? No. Is there a simpler way to write x times x? X to the second power. So all these things get multiplied together. 3 times x times 4 times x. Since order of multiplication doesn't matter, I can go ahead and do 3 times 4 is 12 times x times x.
Which is 14x.
I don't know what x times x is, but I can write it as x squared. Okay, so earlier the first thing we did was like x plus x. Do you remember what we said that was? 2x. And what I just did was x times x, which I called x squared. So sometimes kids get these two confused. Just remember, what does an exponent mean? It means that number times itself, right? So when you're multiplying an x times an x, that's when you do the exponents. All right. And then we got this other guy over here,
6x.
6x. Do those add together? No.
No.
X squared, remember x squared and x are not the same kind. You can only add and subtract like terms. Those are not like. If it doesn't add together here, it's not going to add together here. Not going to happen. Are we panicking? Are we okay?
Wait, how did you get the second power again?
Whenever, because this one, unlike the other ones, has an x times an x, and that makes an x squared.
What happens if they were different?
Different what?
Like x and.
Oh, that's a good question. Let me put a y right there, because there are some problems like that. So, does anybody want to guess what I'm going to do for this one?
12xy.
Yes, good guess. Okay, I can't really do anything with times x times y, so I don't do anything. I just kind of put it in there. I can still do 3 times 4. I don't know what x times y is, and I can't write it any simpler than that. So it just stays. Nothing to do. And then it's still 6x over there. All right. So my goal for today, and I haven't quite talked about everything, but we'll get it here in a minute, is just like 1 through 20, and we'll finish it tomorrow. Tomorrow's is harder because they start making them big problems. Today's is kind of easier, like this. That's about as hard as it gets today. Yeah.
Are you doing the odds with these?
I'm doing the odds. Yeah, anytime it's a hard day, I'm doing the odds. So, actually, let me talk about one more. Let's do one more little problem. just about as hard as it gets today. Okay, does anybody want to guess what I should do first?
Add
Normally parentheses, but can I do that?
No.
No, so I have to do distributive. So it's like this. Okay, here's the tricky thing though. This 3, you probably shouldn't think of as a 3. You should think of it as a -3. Okay? I'm supposed to be subtracting all of this stuff basically. So just think of this as a -3 when you distribute it out. And this 4 you can think of as -4 also. So what's -3 times 2x? -6x. Now the -6x, the negative kind of, when I bring this down, because I didn't do anything with it, becomes like a minus. So they're interchangeable, really. So it's -6x, and what's -3 times -4?
12.
+12, so that means it's +12. You can think of it as -3 times 4, which is -12, but then we're subtracting it, which makes it a +12. Best idea is think of those both as negatives, which makes a positive. Okay, what is 5x minus 6x? Right, we can do this, right? -1x. But usually we don't write 1 or -1. We
So
just
just
put
negative
-x.
x.
If you put a 1, do you think that would be wrong?
No.
It's not wrong, but it's just not something we normally kind of skip that. But it wouldn't be wrong. I wouldn't count it wrong. Okay, and then the +12 is by himself, so he just gets right there.
How did you get to just X again?
5 minus 6 is -1,
Oh, yeah.
but I didn't put a 1 right there. All right, now we're ready.
Yay.
Number 1.
Wait, you are doing algebra?
Do not. Are we ready? You got your paper ready to go?
Wait, what if there are more than one x squared? Like, can we add those together?
Yeah, if they're the same kinds, you can add them together.
Alright.
Okay, on number 1, I think you guys got all your papers, looks like. It says for each algebraic expression. What does algebraic mean?
Algebra.
But what's algebra mean?
Numbers.
Letters. Means letters are involved, variables are involved, good. List all the numerical coefficients. You remember what I said about coefficients?
Yeah.
The numbers in front of the terms, yeah. So on number 1, what are the coefficients?
3, 4, 5.
3, 4, and -5.
-5.
It's best to think of that more like a -5 than just a minus +5. Okay, and then what are the second question is identify the like terms. So on number 1, do they have any like terms?
Y.
Well, name the entire term though.
4y, 5y.
4, right. 4y, I'm just gonna put a space right there. 4y and -5y. They didn't ask us to simplify, we're just listing.
Wouldn't it be -1y?
If we did it, it would be -1y, but we're not doing it, we're not simplifying
That
on it.
sounds funny.
Yeah, I wouldn't write -1y, I'd just write -5. Okay, leave a space and go to 3. Okay, first question might confuse us. What are the coefficients?
-2 and -9.
-9,
No.
1, or -.
Okay, somebody said it.
Negative.
The first coefficient is 1, right? First
Oh.
coefficient is 1. So 1, -2, -9. Yeah, you're right in the other two. Every term has a coefficient, whether it's visible or not. Which terms are like terms? All of them. So what am I going to put? I'm going to put xy, comma, negative 2xy, comma, negative 9xy. Your hand is dying.
Yeah.
You do a lot of writing in your other classes.
Yeah. Kind of.
Okay, jump into 5. Use the distributive property to eliminate the parentheses. So it says 4 times x plus 2y. Nope. Okay, so if I use distributive property, what will that be? 4x, and then plus, right? And then 8y. Alright, number 7. 5x times x plus y. Okay, so the first term, 5x times x.
Equals 6.
X, 5x. Wait.
Okay.
7.
Nope, nope.
Six X.
Nope. Yeah. Okay, why is it not 6x?
Because
Okay, what would make this 6x is if we were doing 5x plus 1x. That's 6x. Why is this not 6x? Because we're multiplying. What is x times x? X squared. So some of you said it right. So it's
5x squared.
yes. Yeah. Okay. This was like the one Isa asked. 5x times y?
5.
5xy. And it's positive, right? So it's plus 5xy.
Oh, I'm so hungry. You know what this means?
Number 9. We're kind of running out of time here. I need to give you guys at least 5 or 10 minutes to work on these. But remember, it's due on Friday either way, so it's okay. Number 9 is not distributive property. What is 3a plus 7a?
10.
10a. That's pretty short and sweet. Okay, I guess I'm gonna erase these. If only it stayed like that, your lives would be so wonderful.
It's so like nice. So nice to just listen to you say bird. So acclimated.
Okay, number 11. I don't think I'm gonna write this one down.
Can we do 12 or 13 now? That one.
Yeah, we're doing 11, 13, 15. We're doing all those. 11. What is 12xy plus 4xy?
16xy.
16xy. Okay, 13. You can only add and subtract like terms. So I see a 1d, which is d, minus 4d. So what's 1 minus 4? So put negative 3d. This is 13. Negative 3d. And then I also see a plus 3f and a plus 7f. Plus 10f. Okay, 15. Which of those are like terms? Y minus 9y. So what is 1y minus 9y? Negative 8. negative 8y. And does that join with the 3y squared?
No.
No.
So what am I gonna do?
Plus 3y.
Plus 3y
Write
squared.
it on there. Okay, I should make a note at this point. Is this the same thing as this?
No.
Okay. Adding a negative is the same thing as subtracting. So, and plus 3y squared is the same thing as 3y squared. So these are actually the same thing.
Oh.
If you look this up in the back of your books, they would have written this one. The reason is because the book likes to put the bigger powers in front of the smaller powers. But these are both the exact same thing. Okay, so that's might make an issue when we're grading. I'll try to remember to warn you, but this is like the more natural way to think of it, but this was the way they changed the order basically. But as long as these are both positive, they're the same, and these are both negative or minus, these are the same. But yeah, these two are the same answers. All right, 17. That doesn't just apply to this problem, it applies to every problem. 4a, I'm writing this one down. 4a plus, parentheses, 2a plus 9. I didn't do an example like this, because there's no number in front of these parentheses. Okay, but what it means is we're not just adding 2a, we're adding the entire parentheses. So we're adding 2a and we're adding the add 9. So in other words, when you have a plus in front of parentheses, it doesn't make any difference. We're just adding this and we're adding that. If this was a minus 9, we would be adding 2a and we'd be adding a minus 9. So when there's a plus in front of parentheses, it doesn't do anything at all. But when there's a minus, it does. We'll talk about that in a second. So what's 4a plus 2a? And then we're also adding the plus 9, so plus 9. Okay, remember 4a plus 9 doesn't mix, right? And why do... We're not distributing the 4a out on this because it's not multiply. We're distributing the plus, but that doesn't really do anything. It just adds 2a. So this is the exact same problem, basically. The parentheses make no difference when you put a plus in front of them. But, number 19, and I'll remind you of this tomorrow because we're going to do more of these tomorrow. Whoops, need more room. On number 19, there's a minus, and that does make a difference. 19 says
2x subtract
2x minus 8y.
plus x.
Did I write it right?
Yeah.
Okay. So this doesn't mean minus 8y. This means minus all of this. Because remember, order of operations kind of means this is all first. So we're not just subtracting this. Kind of like when you're multiplying. We don't just multiply this times this. We're really subtracting both of these. So I could rewrite this problem as 2x minus 8y minus x. I could rewrite the problem like that. What do you think would have happened if this had been a minus right here? Minus x. It would have become a plus down here. If you take away a takeaway, you're actually going to add. But that's not what it said. This is just minus a positive x, which is just minus x. Okay, now how do I simplify this? 2x minus 8y, I can't do that, but 2x minus x.
2.
No.
Would be 1 x.
Right, remember this is 1x.
Just the x.
2x minus 1x is x, correct. And then what do I do with this guy?
8y minus 8y.
Minus 8y. I kind of forgot to mention something. I think I forgot. This is a mistake that people make a lot. if there's like a plus right here, that only applies to this. Did I say that? This minus only applies to this, not the 5, you know? This, anyway. The sign right in front of the number. So, for example, if I had like 8x minus 2y plus 3x minus y. To do the x's, I do 8x plus 3x. That minus does not apply to this. 8x plus 3x is 11x. And then for the y's, it would be negative 2y. Isa, you should be paying attention. You're going to get these problems wrong because you weren't watching. Negative 2y minus 1y is basically what is what? Nope.
Negative 4.
Negative 2y minus 1y negative 3y.
Oh, not 3y.
Okay, that's actually, we're going to do these more tomorrow, but I just want us to understand that. So I only looked at the sign right in front to see what to do with that. Minus 2, minus 1 for the y's. Anyway, okay, try the evens. You got about 9 minutes. And it's not due tomorrow.